morning and welcome back to another episode of 56-Bit Cloud Cafe. I'm Atir Dalal and today we have an exciting episode lined up as we delve into the wonders of the EC2 universe. Joining us, Patrick Camilleri, CEO at 56-Bit. Hello, Patrick.
Hello, Atir. Thank you for having me.
So let's start. First of all, I would like to ask you, some of our listeners might not know much about EC2 instances and EC2 in general. Would you give us an overview about EC2?
Sure. So EC2 is an AWS service. It is one of many services, but it's a very core, very important service. It allows you to create servers known as instances, and it allows you to do so in a very dynamic way. You can have as many as you need, and you can increase them and decrease them depending on traffic. It's important to note how servers and the internet in general, as well as how applications in general work in this age. It uses the server-client model. The server-client model, you can think of it like when you're going to a restaurant. You are the client, and there is a waiter, a server, who is giving you what you need. So for example, the first thing you would do is you ask for the menu, and the server comes back and gives you the menu. Then you would order the food, and the server comes back with the food. Now, it's exactly the same thing when it comes to the server-client model. The clients, usually browsers or applications installed on operating systems, they will ask for something, and then the server will reply with that feedback. And this continues back and forth accordingly. What that server gives you is ultimately up to the application installed on the server, to the software installed on the server. Now, when it comes to EC2, of course, you can do all this on-premise in your own data centers, but if you're moving to AWS, a direct competitor to that would be AWS EC2. You get a server, an instance, you install the software on it, and it becomes that server which is giving you the feedback you need.
That's great. Now, talking about EC2 instances, there are different types. Can you walk us through these types and how our listeners would know what is the best fit for them?
Okay, so EC2 comes with a lot of options, a lot of different types of servers or instances. The reason that AWS gives so many options is because of their mantra that they give as many options as possible to ensure that you can choose what fits you best as a client. And yes, in EC2 there are many of these, but they can be categorized into a number of categories. So the first type of instance, the most common one that is used, is the general category, the general instance types. There are many types in there, but ultimately these have a very balanced approach in terms of memory on that server versus the CPU of that server. So memory is the RAM, CPU is what handles the calculations required. So the memory and the CPU are very balanced. For example, there is a ratio of 1:2, right? This is just an example, but there would be one CPU for 2 gigs of RAM. Now, the general purpose category of instances is the one you usually go for if you don't know exactly what you need, so it's where you start. But then there are others which work better for different types of applications. If your application, say you have a database application, is memory intensive, it requires a lot of memory, you would go for memory instances. So here you would have much more memory versus CPU in terms of ratio, right? So for example, 6 gigs of RAM for one CPU. Then there are the compute instance types. This is a category of instance types which have a lot of CPU. Some applications require a lot of compute power, and here you would have something like, for example, one CPU for each gig of RAM. There are 3 others which are used less, but ultimately, if you have a specific application that requires that, they can be very beneficial and efficient. There is the accelerated computing type. These are servers which have graphical processing units on them, GPUs. GPUs work in tandem with CPUs, and they are much, much better at doing fast calculations. So if your application has an AI element to it, a machine learning element to it, today AI is a very common application that is used, then these accelerated types of compute are really what you need to go for. There are two others very quickly. There is the storage optimized, which have a lot of storage on them. They might even have storage which is considered temporary storage, that will not be saved for a long time. So basically, you choose which instances are better for your application type. You have, as we said, there are compute optimized, memory optimized, general purpose, storage, and accelerated compute types.
Okay, that's perfect. Now, moving on, let's talk about launching and managing EC2 instances. Can you give us like a step-by-step guide that our listeners might use for launching their first EC2 instance?
Yes, so it's very easy. You just log in to the AWS console. If you have permissions to launch an instance, you go into the EC2 console, and from there will be the instances that are running, and you can press on New Instance. From here, you will have a wizard, and you have to put in some mandatory parameters. There are also a lot more optional parameters, but the most important thing you choose is the AMI, the Amazon Machine Image. The AMI is basically how the instance starts. So it will have the operating system on it, it will have the applications installed on it, or you might want to bring up a normal AMI with only an operating system on it, and then you install the application after. That is the main thing. There are some other stuff, but mostly that. And then you press Start Instance and it will start.
So, are there any tips for efficient EC2 instance management?
Yes, sure. So there are many, many best practices that you can use to improve your efficiency on EC2. And these include things like choosing the right instance type. As we said, there are different categories, and inside each category there are different instance types, each with their own advantages and disadvantages. So when choosing the right instance types, it gives you the best value for your money, or the best efficient compute usage versus what you are spending. With EC2, when you are spending, in terms of costs, you pay per hour, or even lower than that, per minute and per second, depending on the instance type you bring up. So if you bring up an instance for, say, 20 minutes, you're going to pay for 20 minutes. If you bring it up for 24 hours a day, you're going to pay for 24 hours a day. Now, this might seem like completely different from on-premise, and that's because it is. On-premise, you have to purchase a server, and then if you make a mistake and that server is not as efficient as you want it to be for the application you have, then you're stuck with it. That's called capital expenditure. In AWS, it's very different. You pay for what you use. So if you bring up a server and you use it for a while, you realize it's not efficient enough, and you bring up a different server to take over, then you are not paying anything extra. You just pay for what you use. This is known as operating expenditure, OPEX. That kind of efficiency can only come with analyzing how your application is behaving in terms of memory, in terms of CPU, storage, networking, whether it's reaching the speeds performance required, and if you need to change, it's very, very easy to change. Another best practice is to have auto-scaling, where you increase the number of servers. So here we're not increasing the size of the server up and down, but rather we're increasing the number of servers. So if you have 1, then you go to 2, you go to 3, to 4, and you can do this dynamically. You can increase and decrease depending on how much traffic is coming in to your system. And finally, another important best practice is to have at least 2 servers, each one in a different availability zone. In AWS, we have regions, which are physical locations. Every region is split into different availability zones. You can think of them like data centers in that physical location. So you'll have, for example, 2 data centers split by huge distances, and you can have a server on each one. If one server goes down, the other will take over. And this will increase your reliability. Of course, there are many other best practices, but those are some of the basics.
Okay, now, always security is a top concern. When it comes to EC2, what are the best practices for securing instances?
Yes, so I would mention 2 very important ones. The first one being that your EC2 instances, they should not be public. They can be public, but they should not. What we mean by public is how they communicate with the internet. When your EC2 instances are communicating with the internet directly, meaning there is nothing between that instance and the internet, there is no middleman, then that is very insecure. It's very easy to hack into and ultimately take control of that server or overload it with requests. What we usually do is we take those servers and put them in a private networking section, a private subnet. This private subnet disallows by default any internet connections directly. So you need middle resources like load balancers or net gateways. Those will be required for any connections coming in or out. And those resources are very scalable and can also be modified to increase security. So that's the first very important point in terms of security, is to make sure your resources are not public, they are in a private subnet. When I say resources here, I mean EC2 instances. And the second one is, how do you connect to your instances? Best practice is to ensure that you have a safe mechanism to connect. Now this depends if the instance is in a public or a private subnet. If it's in a public subnet, you can connect with, if it's a Linux instance, with SSH, which is a protocol that you connect from your workstation to that server. If it's a public instance, you can also connect with it using other means, like for example, Session Manager. This is a service which allows you to connect to the instance without SSH. The networking parts of this is very important, that you close down as much as possible. So the firewall, known as a security group on that instance, needs to be set to ensure that only you, from your IP address, can connect to the instance and not everyone else. If the instance is in a private subnet, you cannot directly connect using SSH, but you can still connect using Session Manager or VPN. And these types of connectivities are much more secure than if you had it, your instance, if you had it in a public subnet connecting with SSH. So I would say those are the 2 main ones, okay? Segregating the network into private and public, putting your instances as much as possible into the private part, and how to connect to those instances. Make sure that only you can connect and choose better, more secure options to connect.
Okay, so in this case, how do IAM roles and security groups play a role in this?
Exactly. So you mentioned 2 things. You mentioned IAM roles. IAM roles, these are part of the AWS authentication and authorization mechanisms. This is what allows you to go in and ultimately connect to your servers. When your servers are connecting to other AWS services, say S3 or Redshift or your database, then you can use IAM roles, which give temporary access to those services. So your server is connecting to S3, and it will get a credential, a piece of text basically, which is temporary. These credentials will allow that server to connect to S3, but temporarily. After say 1 hour, it will require the EC2 instance to get other credentials, renewed credentials. The fact that they are available for just 1 hour means that if they are ever stolen by anyone, they will be useless. So this making sure that your credentials are temporary is a very important piece that IAM roles allow you to do. You also mentioned security groups. We've mentioned this already. Basically, these are firewalls. They are set up per EC2 instance, and it allows or disallows connections to those instances. So again, if you have an instance in a public subnet, you can connect to it with SSH, but make sure that only you from your public IP can connect to that server, not everyone else. This is a basic security best practice. But there are other connections you might need. You might need to connect to a database. Again, allow the connection to that database only from that server to that specific database. The more you close in terms of security groups, the better.
That's great. Now let's talk about auto-scaling groups. How can our listeners take the advantage of auto-scaling for handling their workloads, and what are some key considerations when configuring scales policies?
Okay, so auto-scaling is an important feature, sub-feature of EC2. You don't have to use it. You can have servers which are always on, and they never scale out or scale in. But using auto-scaling is a very important best practice. It allows you to increase and decrease the number of servers, not the size of the servers, but rather the number of servers, depending on the traffic coming in. So let's say you have a website. This website has, let's say, 1,000 people connecting to it every month. Small amount of traffic, that's fine. 1 or 2 servers, preferably 2 for high availability, that will be enough. But then you realize that there is a pattern. And your website, when people are going to work for some reason, because of what you're providing in that website, they will start connecting more frequently. So you have a pattern where at night there is very low traffic, and in the morning there is very high traffic from 1,000 connections per month. Of course, if we take it down into the pattern, let's say you have 100 connections at the same time, all of a sudden you go to 10,000 connections at the same time, just as an example. So from 100 to 10,000, that's a huge difference. You have 2 options here. You can either always have servers switched on to handle 10,000 requests at any point in time. That will be very costly, but you will need to do that if you don't have auto-scaling. With auto-scaling, you can say, okay, at this point I have 100, so I need 2 servers. When people start going to work and all of a sudden using my website a lot more, there is more traffic. When I start going towards those 10,000 requests, then all of a sudden, from 2 servers, I can go to 10 servers, enough for the website to handle those requests in a performant manner, in a fast way. But also then I can reduce those servers back down from 10 back to 2 at night. And this dynamic increase and decrease of servers during the day, during the week, during the year, that is the key to how you are efficient on AWS EC2. It's literally in the name. It's called Elastic Compute Cloud, EC2. Elastic literally means it's like a rubber band. It can increase and decrease the number of servers very, very quickly and easily.
Now we reached the end of our episode. Thanks a lot, Patrick, for this comprehensive overview, and I'm sure our listeners will find this information incredibly valuable.
Thank you for having me, and I hope to do a lot more of these EC2 deep dives, a bit deeper than this. This was just an introduction. I'm sure people listening will find it useful.
Stay tuned for our next episode about EC2. Until then, happy cloud computing. To stay connected and never miss a beat, be sure to follow our podcast channel for the latest episodes. Also, you can follow us on Instagram, Facebook, Twitter, and LinkedIn to know more about all the updates in Cloudfield and to know more about our upcoming webinars and events.